let's get to example 1 then. So the first one here says a circle has a radius of 25.60 centimeters. They want us to find the length of the arc intercepted by the central angle with these two measurements. So first things first, what are they asking us to find? Find the length of an arc, or arc length. So we need to then know that that is this formula, S equals r theta, which means in order to find that, all we need to know is our r and r theta. And they flat out told us that our r is 25.60 centimeters. And why do you think they put 60? Sig figs again. So yeah, we're probably going to give them 4 significant figures unless they say otherwise. All right. Then our theta, remember the only way that this formula works is if it's in radians. That's cool because they gave it to us. So 7 pi over 8. And because this one is in decimals, we're going to change this and approximate with using that 3.14 measurement of pi, not the 180. Because remember, if we put 180 here, it would be in degrees. And if we multiplied centimeters times degrees, what would our unit measurement be for the arc length of a circle? Centimeter degrees? That's kind of weird, right? So again, that's why radians are so powerful. Pi can represent 3.14 as well. This is actually an angle. You'll see what I mean in part B. All right, so multiply that out, see if you get the same thing that I got. And so since they gave us 4 significant figures to work with, they'll either tell you in the directions, so make sure you read, or otherwise we will only give them as much as they gave us. So in this case, 4. So I will take a look at the 5th in order to figure out what I'm going to do at the 4th. So that means for us, we will go ahead and say that the arc length is 70.37 what? Well, notice the only unit measurement that was left was centimeters. All right, pretty easy. If you want to go ahead and pause and try part B on your own, that's why I like to do an A and a B. So I'll show you one and then you guys can try the next to see if you get it. So go ahead and pause it, give it a try. If not, I'll get going on the explanations on this one in just a second. All right, hopefully you gave that a shot. Remember, the radius did not change. It's still that 25.6 centimeters. And this time the angle is 54. So what a lot of people will do is they'll just multiply that out. That'll be one of the 4 answers on a multiple choice quiz or test, and they will move on. But remember, this formula only works if your angle is in radians. So make sure that you know there's one extra part to this. You're going to have to take this and multiply it by, hopefully you remember, we can always multiply by what? That will never change the value of it, but maybe just the look of it. And that's a 1. So we're going to have to get rid of the degrees and change it to radians, which again, you don't need to put. But that relationship that I told you to memorize was that pi radians is equal to 180 degrees. Yeah, you can do 2 pi over 360, but that's twice as big. I'd rather work with something that is smaller. So I'll go ahead and put pi up here, 180 down there for the degrees. And now we can go to our calculator, punch all that in, and get our final answer of 24.13 centimeters. Okay? So hopefully you're able to figure all those out real quick. Again, not a lot to this section. This is a nice second section, but more or less just getting used to working with radians now that we hopefully understand what they are. So example 2 here, more of a real world situation or scenario. And we're going to start by reading the whole thing then, and then trying to figure out what they've given us in order to find what they asked us. So we got Erie, Pennsylvania, irrelevant, is approximately due north of Columbia, South Carolina. Again, irrelevant. But here comes the math, and how do I know that? I see numbers, right? So the latitude of Erie is 42 degrees. Now, hopefully you remember from your previous experience what latitude versus longitude is. Latitude, remember, is that ladder around the Earth, so rotating around horizontally, and then longitude was the long way around, okay, perpendicular to that, up and down. So they're telling us that the latitude of Erie is 42 degrees north, and that north represents the northern hemisphere. And Columbia is 34 degrees north as well. So it says the radius of the Earth is 6,400 kilometers. They want you to find the north-south distance between the two cities. So let's start by drawing what we're on, a circle, Earth. We actually live on it, okay? And what we're going to do with that is we're going to draw what you all know as the equator. And around that sphere now, that circular shape, we have a little thing called the radius. Now I can draw this exactly where it would be, but then it's going to be really, really small because the Earth is so large. So I'm just going to draw this for myself to be able to work with, not so much to be perfect. So when I'm talking about this, I'm talking about north, and we're looking at this almost like an x-axis. And whether it's over here or over here, it doesn't really matter. What we're looking at actually is going from there north. And how much? Well, what of these latitudinal lines would we have? We said that Erie would be 42 degrees north. So if I'm going to draw Erie first, we know the latitude of Erie is 42 degrees north. So I'll go ahead and draw this about at a 42-degree angle. And that would be, I'm going to go ahead and call it E for Erie. And then what we're going to do is take, and we're going to draw the other one, which would be for our other city, which is Columbia, which is 34 degrees north. So again, we'll be starting at that same point of reference, the equator, and we're going to go up this time only 34 degrees. So maybe about there. And when I draw that, I know that's what I'm dealing with. So each one's a little bit different. So hopefully you can see those. Because what we're looking for is from Erie to Columbia. They want us to find the north-south line. And you may be wondering, north-south, that's kind of weird. But remember, they told us that these things are approximately due north of each other. So this actually is the path that it takes on Earth, because remember, it's round. No matter if we're going here to there or down here to there, it's actually all on the outside. Think of a basketball, volleyball, baseball, something like that. Okay, if it's north, it doesn't have to be on the outside, so to speak, because if you just rotate it and turn it, it's still on the outside. Okay, so this is what's a little bit weird. What we're going to have to then do is find that north-south distance. Now, distance being the key, that's what they want us to find, the distance between those two cities. So we're looking for this right here. Okay, we want to find that distance between them, which, if you notice, is on the edge of a circle, but we don't want the whole thing, we just want that part. So this is a long, drawn-out way of asking you to find the arc length. So that's what's kind of weird about being on Earth, is we live on a sphere, we live on a circle. So when we do these things and we say a straight line, it's actually curved. But because the size of the Earth, it feels like it's straight and not on a sphere or a ball. So all we need is R and theta, which is really nice. So what we're going to do with this is plug in what we know and then try to figure out what we don't. So R is the radius. And they told us that the radius of Earth is 6,400 kilometers. Now notice 6,400 could be 4 sig figs or just 2 sig figs, or maybe even 3 in between it. So what we're dealing with is possibly 4 sig figs, but as little as 2. But if you notice the other things that they gave us, 42 degrees and 34 degrees, were just 2 sig figs. So that's the most that we can give back. So what we lastly need is the angle measurement between those two things we call theta. But remember, theta has to be in radians in order for this to work. So in order to find this little angle here, what are we going to have to do? Well, since we said this bigger angle from here to here was 42, and this smaller angle was 34, what if we took the bigger one and subtracted off that one? That would leave us with the part that we wanted. So we're going to simply do 42 minus 34 to get a total of 8 degrees. And when we punch that in your calculator, you're wrong. Because don't forget, that is in degrees, not radian measurement yet. So what I'm going to have to one more time do, which is why I told you it's very important, not just in this class, but most math courses, is multiplying by 1 to get rid of the degrees and get our radian measurement. And we said that relationship is pi radians is equivalent to 180 degrees. So that then is what we could put into our calculator to multiply out and get a final answer of that. But remember, they only gave us a total of 2 sig figs, so we would have to make sure that we don't give them any more. 2, 2, and actually only 2. So we should be looking at the third to see what we do on the second. And that means we would write 8, 9, and then have to keep that down to a 0. 890 kilometers, because the degrees canceled out and radians, remember, are not necessary. So that would be our answer for this one. Pretty cool that we can figure out that distance just by doing some simple trig. So let's try another that looks a little bit different. Now we're talking about the inside of clocks or watches, the old school, not the digital ones that can take cell phone calls and things like that in. All right, so this one has 2 gears that are adjusted so that the smaller one, this one, is the one that actually has the mechanism that makes it turn. And if this one turns, because of these teeth that are in there, it's going to actually turn the other one as well. So if this one is rotating this way, it will push this one that way. Okay, so we have virtually 2 circles here, one with a radius of 2.5 centimeters, the other larger one 4.8 centimeters. And it says if the smaller gear rotates through an angle of 225 degrees, they want to know how many degrees would the larger gear rotate. So this is what's a little weird. It doesn't seem like they give us enough information. They gave us the radii here and here for each, and they only gave us the smaller gear in its angle of 225 degrees. And they want us to figure out what that would be in the other one. So this is what's a little bit different about this particular problem. What ends up happening is if I took this point that they both share right here, and this one rotated 225 degrees, which I know is more than 180, it's about 45 more, so about half. So if I was to break this down into an X and Y axis, so to speak, then I know that this would have been 180 degrees to there, and then it would have been another 45 degrees to get to that 225. So we would end up stopping right there, and we would therefore have this arc length from there to there. But if this is actually rotating from there to there, then what's going to happen as this one rotates this direction, then this one would also what? If it pushes it, it's also going to rotate that same length. So what's going to end up happening is this one's also going to rotate that same amount. And since each of those are what are called S, arc length, I'll call this for the smaller one and this for the larger one, S1 and S2, then I know they're going to actually be equal. And because we know that this is R times theta, as is this, all we have to do is figure out what that theta value is. Because we already know the R values. So the radius of the smaller one is 2.5 centimeters. And the angle they did tell us would be 225 degrees that the smaller one rotated. And the larger, 4.8 centimeters, but we don't know what that would be. Okay, so what do you think we have to do in order to solve this? Pretty simple. Hopefully you can see we now have one equation with one variable set up. Now don't forget, those angle measurements normally always have to be in radians. So what would we have to do for this particular one? Well, we know that those are obviously in degree measurements, but don't forget, they actually wanted us to figure out how many degrees that larger gear will rotate. So in this case, we don't actually have to change it because we know if we did multiply this left side to get it changed by pi over 180, we also would have had to have done the same thing over here, which these are the same, so it's something that we might as well not do. Now, if you want to, go ahead and do it and see if it works out and gives you the same thing. But all I'm going to do is take, and since these are multiplying and I want to know what theta is, I'm going to divide both sides by that 4.8 centimeters so that I find theta and it will still be in what they wanted it to be in. And that's the degrees. Because I know that the centimeters will cancel out because we're multiplying, we can do that. So all I have to do is multiply and then divide to get my answer of 117.1875. Again, degrees would be the only unit measurement left. All right, so don't forget on this one, we would have had 3 sig figs there, 2 there, 2 there. So they're going to either tell you in the directions to just put to the nearest 10th, 100th, or whatever, or in this case, you would have to take the sig figs and round it up to 120. Okay, so whether it's 117.2 degrees to the nearest 10th, or sig figs, we would put 120 degrees. Okay, it's all dependent on how they want the answer. If they specify, cool. If not, do your least number of sig figs, which in this case would have been 2 compared to 3. All right, last one here. What haven't we talked about yet that we also derived at the beginning of this? Area. And how do we find the area of a sector of a circle? And again, you can see they're giving us 2 things, the radius and central angle. So I'm going to quickly draw a circle, and now I'm going to label what I have, just to give you all the visual. So I know that this is a radius of 15.20 feet, and then I'm going to rotate 108 degrees, which means a little bit more than 90, 18 more. So maybe about there. So there is my 108.0 degrees. And again, notice they put some zeros on the end there. Why did they put a 0 there and an extra 0.0 there? 4 sig figs. All right. So with this, hopefully you remember the area formula. We derived it is 1/2 r squared theta, as long as and only if theta is, of course, in radian measurement. And of course, you know they didn't give us that. So just a little bit extra for us to do. We'll take the 1/2, we'll take the r, square it, and multiply it times that theta. So my r was 15.20 feet, and our theta that they gave us was 108.0 degrees. But of course, they gave it to us in degrees, and this equation only works if we are multiplying with a radian angle measurement. So we will once again multiply by that pi over 180. If you didn't have it memorized before this section, you hopefully do now. And now we get to punch all that into our calculator. And just don't forget to also give them the units. And because the degrees cancel out, we don't actually write radians because it's not necessary. You can see the only thing that is left is not just feet, but because we would have to square this, and that we're going to end up with area's measurement of square feet. That's how you measure the area of a home, an apartment, or anything on the ground. Okay, so multiplying that out, you should have gotten 217.75007, etc. And that means for us, because we said that there are 4 sig figs given, and again, if they don't specify, we have to look for that. We're going to take 1, 2, 3, 4 sig figs as well, which means we need to look 1 to the right of that to see what we do with that 4th. So our final answer for the area of just this section of our circle would be equivalent to 217.8 square feet. So again, pretty simple, just making sure that we know how to work with radians, we understand what they are, when to use 180 in place of pi, and when to use 3.14. And if they don't specify, then we will leave it as pi because it's much easier to give them that exact answer than approximating it with that 3.14159. All right? Keep working hard, you guys. This 3rd chapter, again, is very important, building off of the most important chapter, chapter 2, which basically set up the whole class for us to be able to work in with all the trig functions. All right? You guys have a good one. Hopefully you don't feel like me in this jail cell, but keep working hard. We'll get through it together. Until then, have a good one.